Do you understand that point? Right? When you have, without position feedback, you cannot generate current reference, no matter what fundamentals are same. Right? So what we do here is based on the position, we generate a current reference. And this is again an E table we use. Okay, this is basically a sort of a trapezoidal waveform. At 0 degree you have 0 at 9 degree, you have 0 at 27, you have minus 1. At 153 you have minus 1, at 171 you have 0. It's sort of a trapezoidal waveform. You can plot those points in Excel and it shows you the trapezoidal waveform. Okay? So what you have here is, now we take this current reference and actually take this, we multiply with actual output of the speed loop. Because speed loop, so we want to integrate this in speed loop. So this I reference signal comes from speed loop, right? So you take the speed loop, and speed loop, that's a number. So you multiply this with the speed loop output, and then you normalize it. And normalize it such that I max is the maximum allowed winding current in your motor, right? So you normalize it, and that becomes your I reference A. So I reference, so how does it look like? This would be your reference A, which would be basically 0 to 1. When you multiply it with this signal, let's say this signal is 5.
Why we need the sensor?
Then this basically becomes 5.
No more.
And then when you do this,
all sensors are in place.
You normalize with I max. So if I max is 60 amps, right? So you can say basically it is becomes normalized 5 with respect to 60. So this all of this will be something like this. So this is your 0, and this becomes more like 10 by 60. Okay? So, now this is how you handle it in DSP. The reason we have to do this is because in the DSP you don't have any negative numbers. So you take the current reference, you lift it, you multiply it with the output of the speed loop, so you have the current loop, or the torque loop, you can say.
But DSP no negative numbers, those complementary.
See, it's a we also have feedback. So feedback, we want to have an analog when we're feeding, when you're getting the feedback from the inverter, right? That feedback has to be positive. It can't be negative.
From the motor feedback.
Yeah, inverter feedback, current feedback from the inverter. That has to be positive. So that signal gets scaled up, right? So you can take that signal, right, and you normalize this signal to match that signal. I mean, you can do you can do that. Yeah, you can do either way, but the effect is the same. The effect is the same. Okay, so and let's see here. We have.
Now, which are the parameters from the motor to be inputted to this?
There are no parameters here from the motor except okay. So this straight away goes to your error amplifier or your compensator. Okay. This simply is your output of the speed loop. Okay. This is your actual reference, unity reference, which is generated based on your position. So here, this information here, so based on your position of the signal, you are generating your conductors. All right. So that's what we have here. So, and I want to show you, and this is simply, yeah, this is your I feedback A. So feedback is also normalized. You have I reference, you have I feedback, and then you have a simple PI loop. Here also we can run Bode plot because this is a pretty linear system. So we can do Bode plot and we can also do compensation. We can do.
You are telling that there is non-linearity of the torque is there, no?
That's good. We still can do Bode plot with no linearity as long as there's no discontinuity. Okay, so this is the complete motor model. And you will have full access to this in a three-phase system, which you'll be able to play with.
How we have to remove two of the phase, not remove.
No, we'll give you the three-phase.
And no, only one thing you are KE and KT parameters.
Okay, so the torque, how do you, so we calculate what is called power output, right? So the power output is calculated like this. So we have, we take the voltage, back EMF voltage, and multiply with the current. That gives me PA in, right? Per phase power. PA in, so I calculate PA in, PB in, PC in, PD in, D in. Total power is here. What do we do with total power? With the total power, P in and they also P out. Actually, this is the back EMF. That's from the back EMF. This is the back EMF. This is the total power into the motor. P in. And this is the total power out of the motor. Which is the back EMF into the current. This was including the inductance and resistance. This is VA at the motor terminal, right? VA.
So I have to reduce the resistance,
which we already did in the motor model. Okay. So we have now, so when you have this power output, you can also calculate efficiency of the system, right? So when you have this power output, then you go to the last sheet, which is your, okay, so the power output is fed in and you divide by speed to calculate torque. That's how you get torque.
but this is only one part of this story.
This is the whole story.
This is as per the motor story. Motor is not independent of the load.
We have a load there too. See, if you look,
What is more complicated than the motor?
so we have a load here too. This load is a non-linear load. So you can play with the system to your heart's desire. You have the load, you have an actual motor model. You can put the switching model too, but if you put the switching model, then you can't get the torque speed curve.
Cycle you are designing and go up till for confidence.
Good question. So here is how we design it. So our requirements are like this. Top speed is 30 miles per hour. Pardon me?
Very high.
Maximum speed.
Can't reach that.
We reach it. 30 miles per hour.
What is the weight of the vehicle?
We have the lightest motor in the world.
No, weight of the vehicle.
You can put in any vehicle you want.
Oh,
This is for a bicycle.
correct.
The weight of the vehicle.
30 mph for a bicycle is quite high, and the instability of the bicycle will be much more at that speed.
Alright, so let me show you the vehicle parameters. These are the vehicle parameters. So your vehicle weight is 55 pounds or 25 kilograms. Okay, you have one passenger, weight of the passenger is 185 pounds, total weight is 240. Then you have something called projected area. So when you're riding a vehicle, you know what is your projected area to the wind, right? We assume 5 square feet. What is your horizontal drag coefficient, right? What is your rolling coefficient? How many number of motors? Battery efficiency, we assume 80% battery efficiency. Inverter efficiency 95%. Motor efficiency 95%. Vehicle efficiency 95%. Then we have got total system efficiency of about 69%. Battery capacity 9 amp hour. Battery voltage 36 volts. So those are the vehicle parameters.
How much distance it can go?
Let's see that. So
Battery efficiency is the maximum efficiency or what? Depends on the current you draw.
yeah, since normally the battery efficiency is the worst problem in electric vehicles. You have at light loads you have high efficiency, but at higher loads you have worst efficiency because the impedance is very high. So here, if you look, so we can climb 12% grade at 10 mph for 3 miles. We have a range of 18 plus miles at a speed of 15 miles per hour. And we have 0 to 25 miles per hour acceleration in 10 seconds.
What is the depth of discharge
Depth of discharge.
of the battery?
Peak current we draw is about,
No, at the end of 15 kilometers or 18 miles of the range, how much it would have discharged?
how much peak current discharge?
Battery.
Completely.
On gas. If your battery goes down, if your depth of discharge is more than 35%, the life will come down. Clearly.
Not in the lithium ion battery.
Any battery.
This is, we cut off at 28 volts. So
As
per cell,
basically, the rate of discharge, depth of discharge, number of cycles of charging are very, very important. Temperature of the battery will play a very prominent role in terms of life of the battery.
But not in this battery. The batteries we use here, we discharge,
Capacity, how many kgs it will weigh?
it's about 2.5 kgs.
Cost of the expected
Expected cost is about
on the battery alone.
battery alone is about $350.
And life of it,
Life for 1,000 cycles. 1,000 cycles.
1000 cycles charge discharge. Too low, no?
Too low? You show me anything which is more than 250 in India.
That I'm not telling that. What I mean is 1018 kilometers if he goes.
That's
Not
18,000.
telling it is zero.
That's
So
18,000.
18,000 kilometers.
18 miles.
18,000 miles.
What is the selling cost of the motor?
We sell this is mainly for Europe. It's I don't remember. I think it's about $1,000. Motor, battery, and display.
In India, how much it will be? Same.
I don't know. We're working like Indian version.
What is it?
We have electric bike available for that price here in India.
There's a lot of lead acid batteries in there.
No, see, present even our
TVS
TVS scooty type of things. If you try to put it now, that cost is something around 25,000. Okay, and if it is $1,000,
It's more double that.
double that. See, what you are, which market you are looking for?
Mainly looking for Europe.
Maybe some jolly riders, they won't mind spending any amount.
Not a whole lot of jolly riders.
No, one thing. The real selling in India, okay, suppose your mobile has the maximum amount of selling is the lowest strata, and see the number of poles, there is a limit because the size of the outer diameter, you can put this much, almost 100% increase in every parameter.
Yes. That's why it's a breakthrough.
Very little.
That's why it's a breakthrough.
Otherwise, people are struggling.
So that's what. So this is what we have.
And actually, maximum problem comes in your magnetics. How do you really circuit, magnetic circuit design you have done, because all people have really mastered their magnetics. Of all things, magnetics is equally troublesome even in your converters also.
Enclosure, is it molten? Because it's been all the.
Yeah, it gets pretty hot. So it gets pretty hot, but the beauty is that it's a very limited duty cycle motor. So it only remains less than 6% of its lifetime in a high torque area. It's like a car, right? Car, when you're driving it, unless you're driving in India, it's a different story, right? There it's always
Keep
one
accelerating always. In India, you just accelerate.
Here you drive the car in gear 1, right? It's very difficult to go to gear 4 or 5. You're always in gear 1 or 2.
Not that our roads will never permit you to do that.
Right.
Not traffic. The ICs and then the switches, they should be encapsulated.
No, they're not encapsulated. We have a stator plate, I should say.
All in package.
All in cycle.
See, there are the front wheel also there, the back wheel also there.
Yeah, we have a battery also in the wheel, so I can show you.
One side is battery, another side is motor.
Yeah.
Any other construction you evaluated?
We have also another motor called DX, which is a smaller motor. In the catalog, there is also DX motor, which is a smaller motor.
This motor is available as a product?
Yes.
Now, when anything axial flux is evaluated by
We have axial flux design in works. That will take 3 years, 2 to 3 years. We are working on the axial flux design.
your own development on axial flux?
Yeah. So the axial flux, see the next release is going to be low cost version for the Indian market, which is 2012. Is when we intend to release it in Indian market. We hopefully will have a press conference in January or February timeframe where we'll announce this technology. This technology is still not announced in India. So you get to see a pre-launch preview of the technology. But we do a press conference where we get all the big newspapers and then we announce this technology.
How many submanufacturers are in India?
So we manufacture it in Pune ourselves. We have a factory in Pune.
From you, competitors?
There are some competition, yes. Mainly they do brushed motors.
For motors, sir. You mean entire bicycle or only motors?
Only motors.
IAs is developing
Pune, there is one company, actually referred to me. Any motor you do, which specification we are ready to do.
But they import from China.
Yeah, most of them are
Imported as well.
imported from China.
That is better place to
Well, see, we set it up here, so we can hopefully launch the new market.
No, the future, if it is green they are looking for. Show that one.
This is an earlier design we had done. This is a 7-phase motor.
Your target is to increase the number of phases.
No, this was done in 2003.
Huh?
This was 2003.
What you thought it did better?
7-phase
Not
motor.
yet.
7-phase motor. It was okay. It was not with the best.
Europe,
There is some MOSFET switching
There's
losses.
some lock.
The function
Indian
of
power
dot
individual
speed
lock.
Function of
dot speed curve. So you, that's how you do it.
color significant this.
This is which is it is in motor also.
So here it's like for 29 watts.
What stage is the release of this bicycle?
This bicycle we released long time ago.
Ah,
7-phase one is released long time ago. That one is, let me show you. That one is long time released. Now it's not in
production.
No, it is in production. It is being sold in Europe.
So in this time they may be mostly asking for this one. Petrol casting going up.
Yeah, we love that. That's the only time to sell electric
Yes,
bicycles.
yes.
So this was. Anyhow, I showed you a picture of the bicycle. It's called tidal force.
They still,
Yeah. Now it's a very old technology. So it was very